In this section we will learn how to derive Lagrange equations using D'Alembert's principle, and as we discussed last time, D'Alembert's principle can be written as PHY minus PI dot times delta Ri equals 0, and let me name this as equation A. Now we can transform this equation to a form that includes virtual displacements in terms of generalized coordinates. So that is transform the equation to a form that includes generalized coordinates. So the transformation equation will look like Ri equal Q1, Q2, Q3 up to Qn and T. And Q's are actually what we called as generalized coordinates. So let me name this will be equal to Qk dot right, and then plus there is a time component here, so that needs to be differentiated separately, dabba Ri over dabba T. So let me name this as 1.11. That's the next component. And then also the delta Ri on this equation, delta Ri can be written as so when it transformed into generalized coordinates, it will be dabba Ri over dabba Qj times delta Qj and summed over j. Right. So let me name this as 1.12. Now you can see that there are two terms in equation A, that is Fi times delta Ri and then Pi dot into delta Ri. So let's take those two terms separately. That is Fia. So first take the first term Fia times delta Ri. So since there are no other forces except these external forces, so applied forces, I am going to drop the symbol A here, and this will be Fi times delta Ri so just keeping the Fi as it is, I can substitute the value of delta Ri using this equation. So that will be summed over j, and then Fi is dabba Ri over dabba Qj delta Qj, and this is should be multiplied by Fi. Right, so this can be written as 1.13. And from here we can define the generalized force. So let me define the generalized force Qj, which is equal to sigma I if I times tau Ri over tau Qj. So this is when the coordinates are converted to generalized coordinates. You have this delta Qj term here, and this term right here basically represent the generalized force. So instead of force, now we have the generalized force. Now we take this as a 1.14 and now in terms of generalized force, can write the above equation if I delta Ri equal to Qj delta Qj, right? So by substituting the generalized force, now this can be named as 1.15. And just to let you know that the QJs doesn't need to be have the units of the forces, so it should be basically it doesn't need to have the units or the dimensions of the forces, but when you combine Qj with delta Qj, Qj times delta Qj should have the dimensions of work, right? So that is the first term in the D'Alembert's principle, if phi times delta Ri. Now let me take the other term, Pi dot times delta Ri, and see be equal to